Vector method. This is another name given to the method of finding out the resultant of force, and that is graphically by the polygon law of forces. The force by the method of vectors is found out in this particular method. So first of all, draw the space diagram of the given force system, and then we have to select some suitable point and go on adding all the forces vectorially, that such diagram that produced by joining a number of forces, that is called a vector diagram. Here we have two diagram available, 1 and 2, that is called a space diagram of such a force system. Then after the joining all the forces, that the closing side of the polygon that is taken in opposite order will give a magnitude and the resultant of the given force system. So let us try one by one and solve it by a vector method. So here we have to first of all select first force system, and for that force system we have to provide one point O, and from that point O we start with first force, that is 5 Newton, and for that we also required to take a suitable scale that represent actual magnitude of a force. So by applying that and selecting a suitable scale, so here we have to take a scale that is with some length of exactly 5 Newton force. So let us take one very small scale that represent a 5 Newton in a particular given direction of the force. So we make exactly a half of that given force. So we take here a 2.5 centimeter, and considering the direction of that 5 Newton in this particular direction, and we provide a point A here that joining a 5 Newton force. Again we have to measure a 60-degree angle, so that makes with the 5 Newton and the 10 Newton. So here we mark 60-degree, and again draw with proper scale 10 Newton force. So here we have a line of 5 Newton, considering this angle as a 60-degree. So this force is a 10 Newton force, and this is a 5 Newton force. Again we put a name here, that is a point B. Then from that force we have to move to another force, that is a 13 Newton force, and considering again a 60-degree in between that 10 Newton and 13 Newton. So putting here a 60, we have to take another 60-degree here, and again draw a line with appropriate scale. So for the 13 Newton we have to go with 6.5 as a length. So this is our 13 Newton force. Now this is our last point C. So we represent three number of forces that is given in our force system. Now joining that last point and first point in a reverse order, so we have to join that by a dotted line, point O and point C. So that point or that line that represent a resultant R, and the angle that is make with this horizontal, that is the theta for that particular resultant. And if we measure the magnitude of resultant in terms of the selected scale, so here exactly a 3.5 centimeter, so we can say the double of that. So the resultant value that equals to 7 Newton, and the angle if we measure with the horizontal full angle, so that angle is 180 plus this much, so that gives theta is equal to 180 plus, that gives the 20 and 2, so that is 202-degree angle. So this is a final value of the resultant of a first given force system. Now for second system, again we have to take a 1.0 here and then try to draw a line of the force with a appropriate scale. So here we required to take a scale with 2 kg is equal to 2 centimeter, let us say, and that force is acting in horizontal direction. So we put here a 2 centimeter, and that is our first force. So we take a 2 kg is the force. Then second force, that is in this particular direction, and that is of a 2.5 kg. So we can also name that this is point A. Now again taking angle of 40 degree and measurement of 2.5 kg, that means 2.5 centimeter. So we have to take 2.5 centimeter here and again draw a line in particular direction of given force. After that we have to go B to C. So here we point out B and then go to C, so that is exactly a 100-degree angle. So we have to make again a 100-degree, and if we take overall angle, so that is 140. So let us say it is a 140 angle. So from that B if you want to take, so we take a, this is 40, okay, this is 40, and that is again a 100-degree from that, so total is 140. So in line with that we have to draw a parallel line to that, so that gives a total 100-degree, but it is also of a 1 kg, so that we restrict up to a 1 centimeter only, so up to here. So there we point out a point C, that is our third force. So this is of 2, then 2.5, and this is of 1 kg force. After C we have to move on D, that is our final and the fourth force, and that force is completely vertical downward, and the intensity of that force is 3 kg. So we have to move down with a 3 centimeter. So that is our last point, so that we named a D point, and to complete that we have to draw another line, or that is called a closing line, and we have to join a first point and a last point here. So that gives a resultant line, or you can say the resultant side in a reverse order. And in that particular case, if we want to measure the magnitude of that resultant, So we have to measure that line, and that line is of 2.8 centimeter. So we can say that the resultant is equal to 2.8 kg, and direction of that resultant, that again we have to measure with this horizontal. So that angle uh, gives appropriately 12 degree. So this is a final answer of a resultant and particular direction of that resultant of that given system. So this is a method to solve the given force system with a vector method, and that is appropriately known as a polygon law of the force method also.